In this video, I'm going to take a look at 3 different problems from Chapter 11, Exercise 1. And Exercise 1 is just simply on calculating simple events. So for Exercise 1, you just need really 3 equations. First of all, you need the classical theory of probability, which is this equation. The probability of some event A is equal to the favorable number of outcomes F over n, the total number of possible outcomes. So this again is the classical theory of probability, and the probability of some event A is equal to F over n, favorable number divided by the total possible number of outcomes. You also need the relative frequency theory, which is essentially the same equation. The probability of some event A is equal to the number of favorable observed outcomes, and that's the only difference between the two, over the total number of observed outcomes. The only difference again is that the relative frequency theory takes into account observation. Here's the fancy lingo. It's a posteriori, meaning that it's dependent upon observation, thus the O, whereas the classical theory is a priori. And that means just the opposite. Dependent upon observation, that's the relative frequency theory. A priori meaning independent of observation. And so there's not an O there. Many things can be calculated a priori using the classical theory of probability. For instance, if we wanted to calculate the probability of, say, drawing an ace from a poker deck, well, we don't need to draw a card some large number of times and record the number of observations. We can do that a priori. There are 4 aces in a deck, and there are 52 cards in a deck. So many things can be done a priori, but not everything can be done a priori. Sometimes it's got to be based on observation. So for instance, what if we wanted to calculate the probability of a 50-year-old male living to the age of 70? Well, that would have to be done a posteriori. There's no way to calculate something like that a priori. Again, the equations are essentially the same. This one is rooted in observation. This one is done independent of observation. And you don't need to know the fancy philosophy lingo here, but that might help to put it into perspective. The last thing that you need for exercise 1 are the betting odds. And fair warning here, betting odds and probabilities are often confused. But be sure to get this straight. If you confuse probabilities and odds, then you stand to, if you're actually going to make a bet, you stand to lose a large sum of money, or for the test, of course, you stand to lose a large number of points. So betting odds are expressed as a ratio. Let me scrap that here. Betting odds are a favorable number of outcomes to unfavorable number of outcomes. Not total number, but favorable to unfavorable. So those are the odds, and that's the probability. So if you kind of get those down, let's practice here a little bit. Let's take a look at a couple different problems from Chapter 11, Exercise 1. So problem number 3, and this again is straight out of the text. If the standard odds are 8 to 5 that the Colts will beat the Seahawks, what's the probability that this event will happen? So notice for this one, we're given odds and we want probability. So let's keep track of everything. We're given odds 8 to 5, favorable to unfavorable. The question here wants us to figure out the probability. So probability is not favorable to unfavorable, but favorable over total number. So the F part is the same in each, that's 8, and N, we want the total number. Favorable to unfavorable, so total number would just be favorable plus unfavorable. In this case, 8 plus 5, 8 over 13 would be the probability, and that's all there is to it. Number 6, let's go through a couple more. Number 6, if the probability of the Colts beating the Seahawks is 6 over 17, what are the odds for this event? So this is the same question, basically, only this time in reverse. if the probability is 6 over 17, and then this time we want the odds. So let's keep track of everything. We're given probability 6 over 17, F, number of favorable outcomes, over N, total number, and we want odds. Odds are favorable to unfavorable. So again, the F part here is already known. That's going to be 6. We've got the total number, we've got the favorable. So to get unfavorable, total number minus the favorable number, 17 minus 6, the odds would be 6 to 11. And that's all there is to it. One last one here. Practice, of course. There are other problems, 7 other problems, in fact, to go through to prepare for the test. So number 8. This one's a little trickier. If the odds of the Colts beating the Seahawks is 5 to 4, so let's keep track of everything here. 5 to 4, that's favorable to unfavorable. And you bet. So in this problem, unlike 3 and 6, the ones that we've just covered, in this one we're actually going to bet. So in this one we're going to bet $10 on the Colts. How much do we stand to win? So here's the key bit of information. 5 to 4, we know that's favorable to unfavorable. But in terms of betting, this means that for every $5 we bet, we stand to win 4. For every 5 we bet, we're going to win $4. So with that in mind, this actually becomes a pretty simple problem. For every 5 we bet, we stand to win 4. We're going to bet 10. So essentially, we're going to bet $5 twice. We bet $5 twice, and that 5 times 2 is 10. So we stand to win $4 twice. For every 5 we bet, we win 4. We bet $10, meaning we bet $5 twice. So we stand to win $4 twice. 4 times 2 obviously is 8, and that gives us our final answer. I would also accept 18 if you want to think of it as we get our $10 bet plus $8 profit, a total of 18. That's fine. Or if you just want to express it as $8 profit, I would accept that answer as well. So again, obviously continue to practice in Chapter 11, Exercise 1. These are over simple events. There are just 10 problems total. We've done 3 here. The rest of it should go pretty quickly. As always, if you have any questions, don't hesitate to ask.